So we were discussing about the continental margins last week. What would be seen in the continental margin, and right. So today we are going to further discuss a little bit on the plate boundaries. What you can see in the plate boundaries and what would happen. Right? So by now we all know that these plates that the continents are made, it's not only the continents but also the ocean is made of, they are constantly moving. Right? That movement, we will talk about this movement later on, but it's very slow movement. So because of that, you won't notice that movement. So that the maximum speed will be 10 centimeters per year. So it will be somewhere between 1 to 10 centimeters. So it will be very slow. No one will notice that. Right? So, but this movement is very important because that will cause a lot of changes in the continental margin. Right? And especially the change in the shapes of the continents, the shape of the oceans, and forming a lot of underwater structures, or in there's some structure in the landmass. They are all part of this the continental movements. Right? So you won't believe even the Himalaya, the Himalaya mountain range was built because of this movement in the plates. And some of the islands like Hawaii Islands, these islands were formed because of this movement in the continental margin, right? So if you understand well about these the continental margins and what is happening in the continental margins, you can explain a lot of geological features, right? So I mean, we are not going to learn that much of geology, but at least the basics things, right? So what can happen to these plates in the margins? So they can move out. Right? So like the plates are like this and they can move out. Sometimes plates may be apart from, they can come closer. Right? Sometimes even these plates can move side by side. Right? It's like side by side they can move. Likewise, there are three ways that can happen in the boundary. Right? So now what will happen in that boundary will be, because of that movements, depend and will result in different things. Right? Now remember that we discussed earlier the oceanic crust and the continental crust is a little different, especially because due to especially the density is different. So let me show you here. So keep in mind again that this is the ocean crust, like it is thinner. You see, this is the mantle and the bottom, and this is the crust, and this is the ocean crust. Unfortunately, the same color it's shown, it should have different colors then. But anyway, this is the ocean crust, and this is the continental crust. It's thicker than the ocean crust. And the yellow one is the sediment. You see, a lot of sediment is deposited in the marine environment, especially close to the continental margin. Right? So this is we refers to as a continental margin. මේක තමයි continental margin කියලා කියන්නේ. continent එකයි මුහුදෙන් වෙන්න ඕන මේක. So like if you look at some of the geological features around here in the continental margin, you see, if you see a mountain very close to the coastal zone, and that is some sort of an indication, then there is a plate boundary somewhere here. Right? I will come to that one later on. But you look at the difference in the oceanic crust is thin and denser. Why it is denser? You see, the density is 2.9 gram per cubic centimeter, whereas the continental crust is thicker than a coming ready ganathe 2.8 or less than that. Make a look but it's still it's considerable difference, right? So that is there. That is because of the material formed here. It's mostly granite. Continental kalugal kiligan granite, whereas the ocean crust is made of more basalt. Basalt කියලා කියන්නේ lava වල ඝනීභාවන වෙලා සීතල වෙලා ඝනීභාවන වුණාම ඉතුරු වෙන දේවල්. මේ basalt හැබැයි පස්සේ කාලෙක තමයි basalt වලින් තමයි ඇත්තටම මේ granite හැදෙන්නේ. ඒක වෙනම කතාවක්. අපි ඒ කියන චර්ම දාලා නැහැ. Anyway, it's in the basalt, right? But it's denser. The basalt is denser than granite. Okay, so that is so oceanic versus continental crust. Now, as you can see, the oceanic crust is denser, you already know, and also it's younger than the continental crust. Continental crust is denser, but it's old, right? Now keep in mind that one, the ocean crust is younger than the continental crust, right? We will discuss later and you will understand why it is so. Okay. Now here, you look at the world map. So, if you're really interested in a little bit of geology, which I don't think so, at least some of you may be a little bit interested on geology, and look at this map. You see some of these are the tectonic boundaries. That means plates are the boundaries. තමයි මේ රතු පාටෙන් පෙන්නලා තියෙන්නේ. කොහෙන්ද මේ plate දෙකක් වෙන් වෙන්නේ කියලා. මම ඊට කලින් කියලා තියෙනවා ලංකාව ආසන්නයේ plate එකක් නැහැ. ඒකින්ද අපිට මේ tectonic activities ඉච්චර අපිට දැනෙන්නේ. හැබැයි but you look at this the India, the top of the India, see, it's a plate boundary, and then exactly the Himalaya, the mountain range, is right at the edge of this tectonic plate. Right? So that will give some idea, right? And even look at some of the coast, like so you see western coast of the South America, the North America. So along this western coast, you see it's a continental margin. You see the continent separated from the ocean, that's the continental margin, but it is also a plate boundary. You see, a lot of that, some countries like this, the plate boundaries are at the edge of their continent. And now look at here, like in the Mediterranean. Mediterranean Ocean එක මේ ඇතුළට ඇවිල්ලා තියෙන්නේ ඇයි කියලා දැන් හිතෙනවා ඇති මේක මේ බලන්න මේ plate boundary එකක් නේ තියෙන්නේ. මේ plate boundaries වල මේවා ඈත් වෙලා හැදුණු cracks වල එහෙම නැත්නම් මේ වෙන් වෙච්ච තැන් වල තමයි මේ සමහර ocean හැදිලා තියෙන්නේ. මේ Arabian Sea එක බලන්න මෙතන. හරියටම බලන්න මේ මෙතන sorry මේ පල්ලෙන් තියෙන්නේ. මේක හරියටම අර මේ මොහොත ගිහිලා තියෙන හරියටම මේ plate boundary එකක් දිගේ කියන්නේ plate boundary එකේ හැදුණු crack එක තමයි පස්සේ කාලෙක මේ ඈත් වෙලා මොහොතක් වෙලා තියෙන්නේ. අනිත් ඒවත් බලන්න මේ හැම continent එකක්ම වෙන් වෙලා තියෙන්නේ මේ වගේ මේ මැද plate එකකින්ද මේ දෙකේ මේ plate වලින් තමයි ඈත් වෙලා ටික ඈත් වෙලා ගිහිලා තියෙන්නේ. කලාතුරකින් තමයි මේ රටවල් මැද මේ වගේ තියෙන්නේ. හැබැයි මේ බලන්න හුඟක් ජියොලොජිකල් දේවල් ඔයගොල්ලෝ මේ ටික දන්නවා නම් එක්ස්ප්ලেইন කරන්න පුළුවන්. අනිත් පැත්තෙන් ඔය ගොඩාක් volcanic activities කියලා කියන්නේ අපි ඔය භූමිකම්පා, ගිනි කඳු ඇති වෙන දේවල්. ඒවා වැඩිපුර වෙන්නේ මේ boundaries වල. දැන් ඔයාලට බලන්න යන්න පුළුවන්. එතන මේ ඇමරිකාවේ ඉන්න කෙනෙකුට west coast එකේ තමයි මේ ප්‍රශ්නේ එනවා නම් එන්නේ ඊස්ට් කෝස්ට් එකේ කාටවත් ඒ ප්‍රශ්නේ එන්නේ නැහැ. කොහෙවත් බවුන්ඩරි එකක් නැහැ. හැබැයි වෙස්ට් කෝස්ට් එක ඔයගොල්ලෝ අහුවොත් එහෙම කවදා හරි ඇමරිකාවේ භූමිකම්පාවක් වෙලා ඒ වගේ දෙයක් වෙන්නේ හැමදාම වෙස්ට් කෝස්ට් එකේ. not in the east coast. ඒතර ඇමරිකාවෙත් එහෙමයි. බලන්න මේ ජපානයේ තියෙන හරියට මේ ටෙක්ටොනික් ප්ලේට්ස් කීපයක් වෙන් වෙන තැනක මේ ප්ලේට්ස් ඇත්තටම 1 2 3 4ක් ප්ලේට්ස් 4ක් විතර වෙන් වෙන බවුන්ඩරි එක තියෙනවා. so ජපානයේ නිතර භූමිකම්පා ඇති වෙන්නේ ඇයි කියන එක බොහොම ලස්සනට ඔයගොල්ලෝ එක්ස්ප්ලেইন කරන්න පුළුවන්. ඒතර ඉන්දුනීසියාව ළඟිනුත් මේ වගේ ප්ලේට්ස් 1 2 3 4ක් පේස නෙමෙයි අර බණ්ඩාශයේ මතකයි තියෙන්නේ. බණ්ඩාශයේ තියෙන මේ හරිනේ ප්ලේට් 3ක් වෙන් වෙන තැන. so it's very clear that some of the activities that you experience, not we, at least the world is experiencing, is something partly because of this the plates, where these plates are. Right, so hope you got some idea for about the concept. Right now, the plate boundaries. Right, now we look at the continental margins. Right, the one we talk about is the plate boundaries. Right? These are plate boundaries. Now we look at the continental boundaries, right, where the continental crust and the oceanic crust separate from one another. Right? So now look at the sum of the continental margins can be a margin of the plate boundary as well, like in the west coast of US or South America. Right? Whereas the sum of the countries, like in Sri Lanka, right, we are not close to a plate boundary. Right? Because of that, so what we are having, we call the passive continental margin. Right? Since we don't have any plate boundary separating the continent from the ocean, so we are in a passive continental margin. Right? So look at this, the east coast of US and like us. So they are tectonically stable. That means there is no tectonic activities, like no any tectonic activities. I mean, even though there can be smaller ones, like even Sri Lanka, sometimes we can experience some tectonic activity, but it is not a major scale one. Right? Very few earthquakes, and no volcanoes, no volcanic activities at all, like in Sri Lanka. We will never experience the volcanic activities. But there can be a lot of sediment deposits because the geologically not active. There can be a lot of rivers and flowing here because it's very stable. A lot of rivers may be flowing here, and then we will have a lot of sediments in these areas. Right? But on the other hand, look at the other ones with the active continental margins. Right? Just like a west coast of US, there are tectonically active, which means a lot of tectonic activities, very common earthquakes, and even the volcanic activities in such case. Right? Look at here the active margins. They are tectonically active, and there can be earthquakes, volcanoes, and not only that, even there can be some mountain buildings and a formation of igneous rocks. Right? I'll come to that one later on. And on the bottom image, you will see the active margin versus passive margin, the difference. You see the active margins have a very steep slope, and the boundary will be here, and you can even experience a trench because of the boundary here. They are tectonically active, and there is no lot of sediment here. You see that sediment deposition is very thin, but compared to the passive margin, see there is no any trenches, but lot of sediment deposits, and the angle of the the continental slope is very low. Right? It's a very because stores relief very gradual decline, whereas steep slope. Right? So now you look at the like countries based on their continental margins, you can explain the geology a little bit, what is they are experiencing. Right? So the passive continental margins and the active continental margins are marked here in the world map. Right? This is just for your information, right? You don't have to memorize these things. Right? This is just even for your general knowledge. It's very important. You can explain these things, I think, even to others. You see the blue color are the passive continental margins, like in Sri Lanka, all around the India, the Western Africa. I think even the eastern, the east as well as Western Africa, all around Africa is a passive continental margin. But here, the Japan and Taiwan and along that, all the ways are the active boundaries. Right? So as I mentioned before, you see, if you see any like a mountains close to the sea, that is some indication that this is an active margin. There can be some volcanic activity now, but you will see like in the Rumasara in Sri Lanka, we have mountains close to the sea. It doesn't really mean that it is an active margin, but it's another geological feature, but it's not a very big all along the coast. It's just a small landmass. Right? It's not a geologically active area. And you look at the difference here, the active margin, and the next image you will see the passive margin. They are very flat, lot of rivers flowing and lot of sediment deposited. Right? Very wide beaches, and the continental shelf will be very wide and shallow. Right? You will never see a trench along these coasts, and they are geologically passive, no volcanism in these areas. Right? So that difference you can see, right? Okay, there's a small video. We will watch that one and we'll get back.
Welcome to Moo Math and Science and Plate Boundaries. Some of the most dramatic changes in the Earth's crust, like mountain ranges, new islands, or earthquakes, occur along plate boundaries. There are three types of plate boundaries: divergent boundaries, convergent boundaries, and transform boundaries. Convergent boundaries occur when two plates collide. There are three major types. First is continental to continental. This occurs when two plates of continental crust collide. They buckle and thicken, and this causes mountains to form. Next, you have continental to ocean collisions. When a plate of ocean crust collides with a plate of continental crust, the ocean crust is more thick and subducts or goes underneath the continental crust. The magma from the melted oceanic crust rises to the surface, and this results in volcanoes along the boundary. Ocean to ocean collisions occur when two plates of oceanic crust collide. The older, more dense plate subducts under the younger plate, and as a result, the crust melts and creates an island arc. Next, you have divergent boundaries. This is when two plates move away from each other. The separation allows the asthenosphere to rise towards the surface and partially melt. This melting creates magma, which erupts as lava, and then the lava cools and hardens to create new rock and ocean floor or new continental crust. As the crust and upper part of the asthenosphere cool and become rigid, they form new lithosphere, like mid-ocean ridges. Most of these divergent boundaries are located on the ocean floor. However, rift valleys may also form where the continents are separated by plate movement. And finally, transform boundaries occur where two plates move past each other horizontally. When the plates move next to each other, they do not go along smoothly. Instead, they scrape at each other in a series of sudden slippages of crustal rock, and these can be felt as earthquakes. Unlike the other types of boundaries, transform boundaries generally do not produce magma. The San Andreas Fault in California is a major transform boundary. So there we go, 3 types of plate boundaries: convergent, divergent, and transform. Thanks for watching, and Mumu Math up.
Right. So that video explained a bit about what could happen in a plate boundary. So it can be a divergent plate boundary where the plates are moving apart, right? They are moving apart one another, right? So such case we call divergent plate boundary. Now see what happen if you like two plates like this, they are one another but moving away, but only the crust, the top part of the crust is moving, but it will be still connecting from the bottom, right? So what will happen like this, something like this, and they are moving on the top, but it's still connected from the bottom, right? And there will be a lot of tension develop in such case. It's a huge land mass on the either side. There will be a huge tension develop, right? And eventually sometimes that because of that tension they break again, like they move and they come closer, like with a huge sort of a explosive volcanism, and the earthquakes, it can cause huge earthquakes because of that movement. That's what happened in Japan. If you remember, about 10 years back, there was a huge tsunami was generated because after an earthquake, and that is because of this kind of a divergent plate boundary, that two plates were moving away and they eventually break into a huge tension, and that caused that tsunami. Right? So the second one is the convergent plates, where the plates coming together, right? They are apart, but they are coming together, and once they are together, when they are hitting together, they will, they will cause a lot of compression. You know, they compress each other because both are moving, and they will compress with huge power, and that will cause a lot of geological incidents in that area, right? Mainly what would happen actually depend on what kind of a plates are there. Like if it is both land, continental crust and a continental crust, once hit one another, and because both are same, there can be like a mountain building, because it will erupt like a mountain, right? Lot of an earthquake can be happen, but there is no any volcanic activities in such case. But if it is a continental margin, then the oceanic crust and the continental crust, the oceanic crust is denser because of its denser, it will go underneath the continental crust. Continental crust will uplift like this, right? The ocean crust is going underneath and causing a lot of issues, right? And that's what actually happened in the 2004 tsunami. That was in the close to the Banda Aceh in Indonesia. There was a convergent plate boundary. That collision in that convergent plate boundary caused a huge earthquake, and that earthquake caused that tsunami. When you come to the ocean currents, I will explain it. We will further learn about how this happened actually. So that's actually what happened in the 2004 tsunami, a convergent plate boundary collision. Right. The third type of a plate boundary is the transform plate boundary, where instead of coming closer or to, going apart, they will go side by side, right? They move side by side, and such case we call it as a transform plate boundary, right? So what would happen in each case? Here are some of the examples, like in the here it's a convergent plate boundary, a divergent plate boundary, and a transform plate boundary. You see the transform plate boundary, because of its moving side by side, especially through a crack. You can see there are some cracks in the plate boundaries. Right? Along some of these cracks, like there's one crack here, there is a one crack here. In that crack, along that crack, there is the plates moving side by side. Right? So otherwise it won't move. Because of that crack, they will move side by side, making a transform plate boundary, right? And the others is the convergent plate boundary and the divergent plate boundary. We will look at like here, there's a lot of mountain formation and volcanic activities right at the edge of the continental edge of the continent, or in the continental margin, which means this is the active plate boundary, and that's how it happened. So here you can see the three different types of plate movements. That's the divergent plate boundary in a little bit more detail, more graphically. So when the two plates are moving one another, right? So, and there will be a rift valley, like because of there will be some space, a rift valley, and when that valley reaches the magna, then the magna will start coming in, right? But it's like a slow process. There won't be some volcanism here, but it's not like explosive volcanism. But some volcanism will be experienced in this case. Right? The important thing here is, like you see in the rift valley, or there is the crack. The magma start to coming in from the core, right? And that magma, when come to the surface, they will cool down, and new ocean floor will be formed, right? But remember now, earlier I told you that the ocean floor or the continent, so the oceanic crust is usually younger. It is younger because it's continuously forming, because of especially from this the mid-ocean ridges, the new ocean floor is forming, right? And that's why we call the younger. Right? I'll come to this later on when maybe we have time. So what happened in this case, it's a new lithosphere is from the lithosphere, the crust, new crust is forming because of this divergent boundaries that the lava coming into the surface and they will form new lithosphere and there will be some volcanism, but it's not a very explosive volcanism, right? Right, volcanism, but not very explosive, right? Now the second type of boundary is the convergent plate boundary. The convergent plate boundary can be either in the continent or in the continent and the ocean or in the ocean itself, right? So as mentioned before, there'd be a lot of compression here. And what happened, like in the previous case, there was some new lithosphere was formed. Alutin ocean floor එක හැදුනා. But in this case, the ocean floor will go underneath the continental plate, and which means some of the lithosphere will be consumed or lost going underneath the continental plate. So now look at this one. Some of the lithosphere is going underneath the continent and it is lost or is consumed, whereas the new lithosphere is formed in the mid-ocean reaches. ඔයගොල්ලෝ තේරෙන්නේ නැති මේකත් ටිකක් රීසයිකල් වෙනවා. ඒ කියන්නේ සමහර දැන් මේක දිගටම තියෙන එකක් නෙවෙයි. මුහුද පතුලේ අලුතෙන් හැදෙනවා. ඒ හැදෙන සමහර ඒවා අර මේ වගේ කන්වර්ජන්ට් බවුන්ඩරි එකදී ආපහු ඇතුළට යනවා. මේකත් ටිකක් සයිකල් වෙන එකක්. right? Okay. So now what would happen in this case, in a convergent plate boundary, there will be some mountain building because of that collision that will erupt some mountains in the continental plate side, right? And the more important thing, there will be explosive volcanism. If there is any volcanic activities, Gini kandu pupuruna නම් මුහුද ආසන්නයේ තැනක කොහේරි ලෝකේ, and that is an indication it's an active margin and it is a convergent plate boundary, right? Now you know the geology a little bit. Like country like Hawaii, if you go, there will be a lot of volcanism, and that is because of this convergent plate boundary, right? And there can be a mountain building as well as volcanism, and it's explosive volcanism, not like ordinary. It's like this explosive volcanism. It can cause tremendous damages, right? So this is the ocean continent convergent margin, as I mentioned before. The ocean crust go underneath the continental crust. There can be some mountain building and explosive volcanism here, right? And this kind of zone where the oceanic crust go underneath the continental crust, and that we call as subduction zone, right? It calls subduction zone here because it's going underneath the continental crust, and that area we call subduction zone, where the oceanic crust is consumed under the continental crust. So it's a subduction zone. And as I mentioned, there are a lot of earthquakes and volcanoes, explosive volcanic activities, and that's what actually happened in 2004 tsunamis, which caused huge impact to the whole world, like a major part of the world, right? Okay, so these are the three incidents again, the oceanic and different continental margins. What would happen all depend on what is happening in the continental margin, whether they are come closer, going apart, or whether they are going side by side. Some tsunami can be also generated in a transform boundary area, right? And the other thing is the continental boundary, right? That also usually, since this same densities, they will cause a mountain building, and that's exactly what happened in the Himalaya building. I'll show you another area. This is the sorry. The last diagram is the continental. The in the margin is a convergent boundary, right? Continental convergent boundary. Here is a convergent boundary, but oceanic. The both plates are in the ocean. Now, theoretically, since both are in the same density, we should expect, just like what happened in the continents, they should hit one another and will cause like a mountain. But in this case, in the ocean crust, it's a little different because the older the ocean crust is a little bit denser than the newly formed. හරි මතකද දැන් අපි කිව්වා අලුතෙන් ocean crust එක අර මේ mid ocean ridge එකකින් අලුතෙන් හැදෙනවා කියලා. ඒ හැදෙන අලුතෙන් හැදෙන ඒවා density අඩුයි. ඔය පැත්තට හරි වැඩිපුර ගිහිලා තියෙන density අඩු එක. density වැඩ old මේ crust එක තියෙනවා නම් මේ දෙක අර density වැඩි එක අතුලට යනවා. මේ උඩට එනවා. ඉතින් මේ විදිහට මේ ocean convergent boundary එකත් අපිට බලන්න පුළුවන් මේ වගේ subduction zone එකක්. එතකොට අර කලින් කිව්වා වගේ volcanic activities වෙනවා. කඳු පන්ති දෙන්න පුළුවන් වෙරළයි නේ නම් මුහුදේ වුණත් වෙන්න පුළුවන් අපිට ඒවා පේන්නේ නැහැ. හැබැයි ඒ වෙනුවට සමහරට මේ වගේ islands අලුතෙන්ම හැදෙන්න පුළුවන් මුහුද මැද. මේ කියන අර කඳු පන්ති හැදෙනවා වගේම island. And that's what exactly happened in the where the Hawaii Islands කියනවා තියෙනවානේ. Hawaii Islands නිකන් එක chain එකක් වගේ තියෙන්නේ. අර එක සැරේට වෙච්ච මේ convergent boundary මේ collision හින්දා එකක් හැදිලා කාලයක් ගිහලා එකක් හැදිලා ඒ වගේ නිකන් පේලියට දැන් තියෙනවා මේ islands කීපයක්. And that's all these are a part of this ocean convergent boundary, right? So again, you will see a subduction zone, volcanic activities and earthquakes as well. And other than that, there can be some island formation as well, right? So sometimes like trenches as well, right? So it's very clear. Of course, it's a little bit difficult, lot of information, but it's very clear what would happen. Even now you can predict what would happen in a particular boundary, right? So this is the oceanic plate boundary, just like what happened in the Hawaii. That will cause a trench, the subduction zone, some island formation, or sometimes even there can be a chain of islands. So that's what usually you would see. And again, if you come to the Himalaya, look at this, the Himalaya whole mountain range was built because of this collision in a convergent continent plate bound. So there had been a lot of earthquakes, but in this case, you see there is no any magma coming out from here because it's all continent crust hitting one another, and you won't see any volcanism, right? But this happened a long time ago. And you see here, so this is the Indian plate where Sri Lanka also residing. And the top there is a Eurasian plate where the China, Burma, Pakistan, Bangladesh, all countries are in one plate. Eurasian plate, and this is the Indian plate. That Indian plate can be somewhere very further in the Indian Ocean, and this whole landmass has come closer to the Eurasian plate gradually. So it's a convergent zone over millions of years. Right, or millions of years, they are coming together, or coming closer and hit one another and making Himalayas. Right, what we see today here, Himalaya is due to this convergent plate boundary. Right, so it's very clear. All right, so the third type, as I mentioned, is a transform plate boundary, where the plates are moving side by side, right? So along the cracks, right? Like here you can see in the cracks, you will experience this kind of a transform plate. Usually these transform plates are in the mid-ocean, right? This side-by-side movement are usually in the mid-ocean regions, but there can be, as that video also explained, in the US, there are some transform plates that you can see in the land as well, right? So the cracks, you will see the changes, like this is the plate boundary. Now we see the line is breaking apart. So it's a plate, transform plate boundary. Only the obvious difference is this change in the line, we call the faults line. And there can be earthquakes, but there is no volcanism in this case, right? But a lot of earthquakes due to this transform plate boundary, but no volcanic activities, right? So, and here you can see the Atlantic Ocean. This is the mid-Atlantic Ocean, the ocean ridges. And you can see here along this crack, the one plate, right? This one is separated from the another plate, like here, right? They are moving side by side. And another one here, one here, like it's changing the direction. Even here, a little bit of a movement, right? So it's very obvious, the transform plate boundary, right? So this is again a world map which showing where the convergent plate boundaries are, where the divergent plate boundaries are, and where the transform plate boundaries are. In the somewhere in the middle of the ocean, usually in the transform plate boundary. But sometimes there can be a transform plate boundary, like in here, and between the Europe and the Africa. Likewise, there are some cases of a transform plate boundary even in the right in the mid Atlantic Ocean, sorry, in the Pacific, right at the edge of the west coast of India, the US, right? All right, so that's all about the plate boundaries. Of course, there are a lot of information about this thing, but for you as oceanographers, you don't need really a big theoretical background. I just need to give a background geographical information, which you can understand the ocean flow much better. Right? And now the question we will have, how these plates move, right? Since a huge plate, several kilometers deep, hundreds to 1,000 kilometers sometimes deep, mostly hundreds. How this huge slab of plates move, right? So there are a lot of theories to explain this concept, but basically it explained as a sort of a convection current. You know, it's because the continental crust here is the solid part, and the underneath the The mantle is more or less the fluid or liquid magma, which have some fluidity. We can move, and that's some convection current here. Now keep in mind that in the mid-ocean ridges, new ocean is formed, and that new flow move to the either side of the ocean floor, and they are lost in the convergent plate boundary, right? The ocean to continental convergent plate boundary ki මේක මේ විදිහට consume වෙනවා. දැන් මේක නිසා යම්සි convection current එකක් වෙනවා. It's very slow convection current, and that scientists believe this is the reason for this the movement of the plates, right? So that makes the plates moving a little bit slowly, right? මේක තේරුම් නැත්නම් just forget about that. I just want to explain what is happening in the ocean flow, right? Now, this concept of new ocean flow is forming, right? The formation of new ocean flow, we already discussed that the ocean floor is younger than the continental crust, and this concept of ocean flow formation is called the ocean flow spreading, right? So ocean flow spreading or the new ocean flow formation, and the always the old ocean flow is consumed in the trenches, again that convergent plate boundaries, they will consume the ocean flow, older ones, and in the mid-ocean ridges, new sea bottom will be formed, right? So then likewise, gradually the ocean floor is also recycling, so that just keep in mind that one, right? So that's all about the ocean boundaries and what's really happening underneath the ocean, as well as in right at the edge of the ocean and the margin of the